And while they're doing that, I'm going to introduce the first panelist, Rick Parnell. Rick Parnell is the CEO of the Foundation for Climate Restoration, F4CR. Rick's work with F4CR is a natural extension of his 16 years with the United Nations Foundation. There, he put together a team of over 300 folks that, under his leadership, mobilized more than $2.2 billion in funding dedicated to helping the UN solve a range of global problems, including climate change, or work on, not necessarily solve. And Rick currently serves on the board of directors of the U.S. Fund for the Global Fund to Fight AIDS, Tuberculosis, and Malaria, and sits on the boards. Also, let's see, you're a member of the Cosmos Club of Washington, D.C., and the Economic Club of Washington. Rick, I have a starter question for you. What's the mission of the Foundation for Climate Restoration, and what do you see as its role in this climate crisis?
Great, thank you. Let me just say that I'm thrilled to be here. I've spent a lot of time in rooms full of diplomats. I've never spent so much time in a room full of scientists, and so I'm learning a lot, and this is really great. So thank you for having me here. So let me say something about the mission of the foundation. I spent, almost 2 decades at the United Nations Foundation, and when I left the foundation and I was thinking about the next chapter, and I was approached by the founder of the Foundation for Climate Restoration, something that really struck me is there's been so much back and forth of what does 2 degrees mean, and what is a tipping point, and are we doomed, and a lot of it, and I love the Al Gores and everyone in the world that have woken us up over the last couple of decades, but I found so many people were paralyzed. Well, what do we do? What is our role as a citizen, as a human, as a part of humanity? So when I was approached about starting this foundation, one of the things that we wanted to do was to provide opportunity for people to engage, local, national. You have a voice, you have a role to play. So, everything from direct capture that Klaus has talked about, some of the things that you heard this morning, the work that Leslie is doing on restoring Arctic ice. We're working with some people on ocean restoration. The biggest role that we're playing, I think, over the next couple of years is to have people understand that they have a voice and that we can get there. When we were talking about tipping points this morning, one of the things that struck me is I have found over the last 6 months, and certainly in the last 15 days, so many people have been calling me, emailing, and there is sort of a reverse tipping point of people are starting to say, it's 2020, it's time to get on with it. Now, this is not everyone, but I'm finding that family offices are calling and saying, the IPCC report in the fall of 2017, we have to start doing something. I'm finding a lot of corporations, not every one of them, but a lot of corporations, the C-suite, they have children and grandchildren too. They know they have to change their business model, but they're not sure how to do it. The UN is one of our partners. We're working with the Vatican. We're working with multiple faiths. We're working with Broadway. We're working with all different sectors to try and help people make the shift that we should be calling for some of these kinds of solutions. I think a perfect example is that tomorrow there's going to be a press conference in Santa Clara County in California, where the county has become the first climate restoration county in the United States. And they're calling on all counties across the United States and the world to become restoration counties. What does that mean? It means that their planning and their procurement moves to carbon negative concrete as a requirement, as opposed to strictly straightforward concrete. So if you're going to build in a carbon negative way. There's technology out there, it needs to be scaled. Many, many, many examples like that, but that's the kinds of things that we're trying to do. We're working on the Hill to try and get legislation done. We find that our role, we are not experts. Our role is to work with the scientists, to work with the foundations, to work with the UN, work with other organizations to try and help people make that jump that we can get there, and then just keep pushing to get it done.
Thank you, Rick. Next, I'm going to introduce Leslie Field. If you were here for the first session, were you? Raise your hands if you were. Great. Well, so you'll have to bear with a little bit more. Most of you weren't here, so this is good. Leslie is the founder and CEO of ICE 9/11. It's a nonprofit and is dedicated to climate restoration, starting with restoration of Arctic ice. Leslie's been working to save polar ice since 2006 and was the founding director for the Foundation for Climate Restoration's Polar Restoration Action Group. Leslie earned her BS and MS in Chemical Engineering from MIT and her MS and PhD in Electrical Engineering from UC Berkeley, with a specialization in microelectrical mechanical systems and a minor in materials science. Leslie's also an inventor with 54 patents and has worked at HP Labs and Agilent Labs. And Leslie also teaches a very interesting class at Stanford University. I'm sure she'll tell you more about it. And I think, are you going to start with slides, Leslie?
I'd love to. Yeah, thanks. Should we trade or? Yeah. So I think I'm going to try. Okay. We'll see how this works. So you can see I'll be talking about ICE 911 research. In honor of those of you who were here before, I'm going to go faster through the NASA video, if I can figure out how. So this is a beautiful video that illustrates the urgency of what we're going to be talking about. And let's see if I can pull off speeding up. What you'll see here, before we get started, this is month and year of basically what the sea ice age is looking like. And sea ice age goes with brightness. And so that's very important. We've lost a lot of reflectivity in the Arctic. And those of you who saw this before, I hope you're not bored yet. And so this starts off kind of slow. Whoa, well, that's faster than I intended. Gotta say, that was a little overshoot. This starts off slow. We're a bunch of years ago. And so I'm going to try to speed it forward if I can pull that off through this. I will point out, as we're getting closer to where it gets really exciting, that we've got open ocean here with low reflectivity, first-year ice with a little more reflectivity, multi-year ice, which used to be prevalent in the Beaufort Gyre here, or Gyre, for the last 700,000 years, a bright heat shield here, and a lot of ice flow out through the Fram Strait. These are interesting things to note and very relevant to what we're doing. We've done field work up here at Point Barrow for 3 field seasons on a lake, which has been interesting, field testing what we do, very small scale tests. You can see that as time goes on, basically we're losing all this multi-year reflective ice, or a great deal of it. NOAA's report card from 2018, December 2018, said that we'd lost 25%. I'm sorry, we had lost 95% of the most bright reflective ice in the Arctic over the last few decades. And you can see here, this is where the action has really started, where you can see that relentless decline, that positive feedback loop has led to almost nothing left of bright multi-year reflective ice and no natural way back. So a moment of silence here for these last few years to bring us to now. Not good. And the problem with this is, why do we care? The problem is that this has, some experts, Professor Peter Wadhams in the UK, has put in his book, A Farewell to Ice, the sobering fact that up to 50% of global temperature rise, addition to what we already have embedded in the atmosphere from the greenhouse gases there. So we've got a rate of global temperature rise that's pretty tragic. We've added another 50% on top of that from the loss of reflectivity in the Arctic. Because in essence, we've put on a black t-shirt in the summer where the sun is shining, all day, versus the white t-shirt we used to have, if you like layman's terms. So what do we do? And this is where we've powered through that first part a bit, but we'll talk about this a little. We're using a material, the safest material we've come up with, most effective, most practical that we've come up with so far, is hollow glass microspheres. And these things, they sort of look like your plastic microbeads that you're cleansing your face with, but they're not plastic. Deliberately, they're silica. It's a more natural material that we have all evolved with. There's so much silica in our environment, and we've all evolved with it. It's basically floating kind of beach sand, you could think of it as. And we use an ultra-thin layer of it to basically make open ocean isn't very reflective. What we're working on is first-year ice, thin ice, and taking, yes, it's more reflective than open ocean, but not much reflectivity at all compared to thicker multi-year ice covered with some snow. If we put just this really thin layer, a couple hairs widths, over selected areas of this first year, this not very reflective ice, we can boost its reflectivity enough that climate modeling is showing that if we do this over some limited strategic areas, we can actually bring ice cover back over much of the central Arctic, over those areas that we have historically had ice, and we can reduce the risks of things like ever increasing permafrost melting and methane emissions from that, which is a big deal of de-risking climate. So we're very excited that this restoration effort, this Arctic ice restoration effort, could really have some profound results. Where we have started our climate modelers with is looking at the Fram Strait here. Sorry, I'm failing on the pointer thing. But you can see Fram Strait in that green rectangle to the right. That's that area where you saw a lot of ice export out past Greenland. It's looking very promising, very effective per unit area by order of magnitude, more than an order of magnitude, in preserving ice and rebuilding ice to do just this limited area that's about 0.5% of the area of the Arctic. Ultimately, we're also modeling that other area in green to the lower left, which is the Beaufort Gyre, that area of historic ice shield, the biggest part of ice shield in the Arctic. And so the point is, we want to do a limited, very thin layer of materials over a very limited part of the Arctic. We certainly don't want to carpet the Arctic. And with that, what we're thinking, ultimately the cost of doing an intervention like that in strategic areas is something on the order of $1 to $5 billion per year for each limited strategic area. We're thinking we need an annual application. We're thinking that we need to, keep doing this over time. But you compare it to this $2.7 trillion that has already happened in the last decade of tragedies, tragedies that were not prevented in time, and all the devastating impact that's had, so that the cost of even doing this at scale is just minimal compared to the cost of doing nothing. And of course, you are all here aware of what these devastating impacts are already on species and ecosystems and human beings and infrastructure. So it's well worth doing this. What we're looking for, I will fill this in a little more for this panel, is in concert with the Foundation for Climate Restoration and such. We are finding that equally important to the technical end of things, which is my great love, coming up with a solution and driving this to a practical solution, is to help catalyze the policy, the governance, the permitting, because trust me, the last person you want to trust to make the decisions, this is in the best interests of humanity, is not the person who's come up with the idea that they're talking about, right? You want an external governance. You want external permitting. And this is what we very much want, and we want something like UN or whatever international body is going to come and make these decisions on what's in the interests of humanity to be funding these things once they're at scale. What we do at this point, and what other climate restoration efforts do, because we're not alone, are these small-scale field tests to demonstrate the efficacy, the safety, and pivot a little bit if we need to, if we find that it's not quite safe for this critter in this area. All those technical details, which is much less than the kind of costs that we're seeing here. So get that R&D done. Our goal is over the next 3 years to have that completed so that then this can start being implemented. But at the same time, we need to catalyze, help with, some practical advice on maybe what is needed in the way of permitting, governance, and frameworks so that we can have fair rules for everybody to be implementing their solutions. Thanks.
Thanks, Leslie. Great.
Come back.
Creative solutions. Next, I want to introduce Dr. Phil Duffy, President and Executive Director of the Woods Hole Research Center. Phil's doctoral work in applied physics at Stanford led to his work in the nuclear weapons complex at Lawrence Livermore Lab. He tested nuclear weapons and worked on strategic defenses against ballistic missile attack. But since then, the bulk of his career has been devoted to a different, equally important threat, global climate change. He spent 20 years studying climate change as a research scientist and 3 years at Climate Central, ending as their chief scientist. Now, Climate Central might be familiar to some of you. It's a great resource for broadcast meteorological communicators of materials on climate change. And if you attend our next, I guess it's our last panel, you'll be able to find out even more about Climate Central because we have Bernadette Plackey-Woods on that panel. She's the chief meteorologist and program director for that program. You may have encountered Dr. Duffy on any one of a number of national media outlets, such as the New York Times, the Washington Post, Science, the Boston Globe, NPR, CNN, and MSNBC. And I believe Phil spent a bunch of time in the Obama White House where he was involved in international climate negotiations, domestic and international climate policy development, and coordination, really, of U.S. global climate change research. Thank you, Phil. I have a good first question for you. You've stated that emission pathways which limit warming to 1.5 degree involve science fiction, or AKA magic.
Yeah, sure. I'll tell you the story of that. First, I got to thank you for outing me as, well, a lot of my tree hugger friends are pretty horrified when they found out that I actually detonated nuclear weapons in my past. But anyway, so yeah, the story of, well, my involvement with negative emissions starts with the time when I was a White House staff member advising folks there on climate change and climate science. I should say, when I left in 2015, I was succeeded by a gentleman in the front row here, Don Mobles. So I was at that time a delegate to an intergovernmental panel on climate change, a so-called approval session, where governments approve, actually, it's sort of an amazing process. Governments approve literally sentence by sentence these 30-page summary documents. And so when you read an IPCC summary document, remember that literally every sentence in that document was approved by 195 governments, and not only that, was approved unanimously by 195 governments. As you can imagine, that's a very, very painful process. But it also results in very, very cautious statements, because if you do a little exercise of getting everybody in this room to agree to, put a sentence on the board up there and ask everybody in the room to agree to it, it gets watered down pretty quickly, right? I mean, you can imagine that. I mean, if I wrote "the sky is blue" on the screen up there, a bunch of meteorologists would jump up and object, well, not when it's cloudy, and so on and so on, and you would end up with all kinds of qualifying language. And that's why IPCC reports read the way they do. They're sort of the least common denominator. Anyway, I'm rambling on and on, but this was the first time I had, as a scientist, contributed to IPCC reports, but I had never contributed or, frankly, before read the third volume, and the third volume is the economic modeling of pathways to reduce emissions. And I was horrified to see a graph similar to one that Klaus showed earlier, which is emissions trajectories, meaning what do emissions of greenhouse gases need to look like over time if we're going to limit warming to 2 degrees or 1.5 degrees. And what horrified me was that, so there's a curve of annual emissions as a function of year. And what horrified me was that pretty quickly that curve goes below zero. It goes way below zero. And at the time, these scenarios were calling for massive, massive, massive negative emissions. And my reaction to that is what the hell is this? Massive negative emissions, and how are we actually supposed to do that? And the reality was then, and is still largely true today, we really don't know how to do that. It's not that we don't have ideas, and Klaus has very ably summarized a lot of them. We do have ideas for how to do that, but we really don't have proven technologies that can be applied at the scale that we need, which is massive, and with the costs that we need, which have to be much lower than the costs are right now for most of the technology. So if you read the IPCC 1.5, well, the IPCC was roundly beat up, I should say, for this, I think, excessive dependence on negative emissions in meeting United Nations climate goals. And if you read the 1.5 degree report, they were careful to show some scenarios that rely less on negative emissions. But I'll just add one point to that. I think the slide that Klaus showed illustrated this, that on those curves of emissions, year by year emissions, the curve that's highlighted the most is humanity's net emissions, and net means just that. It's the sum of emissions minus, the mathematical sum, emissions minus removals. And so you see the net emissions curve goes below zero around 2050, but in fact, that's the net emissions, and in order to achieve net emissions of zero by 2050, we have to start significant CO2 removals by like 2030, 10 years from now. So, we are still, I think, we still don't have the solution to climate change, and Klaus is right. I mean, the CO2 removal is not optional. At this point, we have delayed long enough in terms of reducing emissions and reducing additions of greenhouse gases to the atmosphere that we absolutely have to have massive removal. And I'll comment later on the role of natural climate solutions, which Klaus has already introduced.
Great, thank you. Well, we've done everybody so far as introduction goes. I have one more question for you, Phil. In our third panel today, by the way, we're going to look at the interactions between and the efficiency or the efficacy of a variety of specific climate solutions and policies. And some of these relate to mitigation and some relate to drawdown. Can you comment on the pros and cons of natural climate solutions versus so-called unnatural or perhaps industrial solutions?
Yeah, no, happy to do that. I should say Woods Hole, one of the things we work on at Woods Hole Research Center is, we work in a large area for us is the role of natural systems in climate change. I just say the multiple roles of natural systems. Natural climate solutions refers to the idea of deliberate management of land systems for the purpose of removing carbon dioxide from the atmosphere. And I should say also, a lot of that is simply the reversal of things that humans have done, namely, for example, the reversal of deforestation, which, if you sum it up cumulatively, has added a lot of carbon dioxide to the atmosphere. Also, the reversal of loss of carbon from soils, and particular agricultural soils. Again, if you add it up over time and over space, we think that the cumulative addition of carbon dioxide to the atmosphere from agriculture has been very substantial, and in fact, roughly similar to how much has been added from deforestation. So in principle, you can put all of that back. And if you look at the theoretical potential of these so-called natural climate solutions, it is rather large. And I guess that's part of the good news. That other advantages, as Klaus I think said, we can do this now. We don't have to do more research and development. We pretty much know. Well, restoration of forests, there's no technology really needed. There's a lot of activity on how to restore soil carbon. I think we are pretty sure we know how to do that and can do that at scale. So we can start now. The cost is relatively low, and there have been a lot of scientific studies, including some that we've authored, which look at the potential for soil restoration, forest restoration, and so on, and break that down by cost. This is how much we could restore for less than $30 a ton. This is how much we think we could restore for between $30 and $100 a ton, and so on. So we think we have a handle roughly on how much could be done for what cost. And again, the cost is fairly low. The potential amount removed is substantial, and also the co-benefits, the side effects of this can be helpful. Restoring forests is good for biodiversity. Restoring soil carbon is good for soil health, and arguably anyway can improve crop yields. So there's some good reasons to do this. There are some significant disadvantages to these natural solutions. As I said, the potential is high, but it's not high enough. It's clear that the amount of carbon removal we need to do can't be achieved entirely through natural systems, and also it's easy to calculate, how much could theoretically be done, but, achieving that on the ground you're not going to do it. I mean, there are very, very substantial practical barriers to achieving anything close to the theoretical potential for natural climate solutions, and including, that these solutions do tend to tie up a lot of land. Reforestation can remove a lot of carbon, but it ties up a lot of land. There's no economic incentive for you don't make money off a standing forest. You make money off harvesting forest. And so, the economic incentives, although the cost is relatively inexpensive, the economic incentives right now aren't there. There's also issues with permanence, meaning that it's easy to add, or we think it's easy to add carbon back into soils, but in a minute you can remove that again by tillage or something like that. And there's also issues with permanence of forest restoration. Another challenge which we actually work on, is measurement. And you can't control what you can't measure. Measuring forest carbon is actually fairly straightforward. We do that through a combination of satellite remote sensing and in situ measurements, and that I think we know how to do that pretty well. Measuring soil carbon is a real challenge. We're working on that. We have good, I think, relatively cheap solutions, but it still requires going out into a field and taking a sample of soil. And what we've been able to accomplish with our work is move from a paradigm where you had to take a soil sample and bring it back to a laboratory to where you can take a soil sample, put it in a handheld instrument, and do infrared spectroscopy on it and get a reading right there in the field. But that is one of the challenges of natural climate solutions. So there's advantages and disadvantages. Again, I think Klaus summed it up well. It's pretty cheap. There's pretty high potential. We can start now, which is good. And so while Klaus is perfecting the vacuum cleaner, we can we can get busy exploiting the natural pathways and get started on the challenge.
But not a vacuum cleaner. We are not pulling on the air. but some of the competitors do. I'm actually a little more optimistic than you are that we haven't proven it yet. Basically across, because we never had a need to get to that scale. So don't be surprised if there was never an economic incentive to do all that. It just doesn't hang around and say, oh, I'm ready, you just pay me, right? So all of these things have to have learning by doing, and that doing will only happen if you put an economic incentive in. Where I'm pushing back a lot is people say, we have great uses for the CO2. And up to a point, yes, but I would point out, I can't ever see air capture compete with a lump of coal as a source of carbon. It's just cheaper to dig it up. So my point is, at the end, you have to treat it as a waste management system. And that will give you cost. The company called Waste Management makes pretty good money on me, because by regulation, I have no choice but hire one of these companies to pick up my garbage. I can't just say, I changed my mind and I bury it in the backyard. That's that's not allowed, right? So, but the regulatory framework, they are not in the business of selling the goods after I discarded them. What they sold me is a service to take care of the problem. And so I think once you establish that, industries will spring up around it, and that's why I like the certificate approach, because we can all benefit from this. You'd get a certificate for the forest you put up, I get a certificate for the underground reservoir I stored it in, or for the mineral carbonates we made. So we all end up benefiting from having a technology which says, or a system which says, we know how much you put away and you get paid for it, but you get paid for it as a disposal option.
Great, thank you. I think we're ready to take questions. If anyone has one, head to the mic.
Hi. So a lot of lawmakers have said that climate change is a technological problem, it's not an economic problem. And that like technology, as it evolves and it gets better, then that'll solve the issue of climate change alone, which, I mean, it's controversial to say the least. But as the price of renewables and high albedo silicas and carbon capture, that's all going down, it's all going in the right direction. But do you think that there are any specific policies or subsidies that like lawmakers can enact that can help us get in the right direction?
It's good for anybody, any of our panelists.
Okay, well, that's that's raw meat in front of climate change it's not going to solve itself. It is a market failure, and that's why the problem exists in the first place. And as Klaus was just saying, it's essential to address the market failure, and I can't underscore that enough. If there were a price on carbon, then all the incentives for implementing natural climate solutions would change. The incentives for deploying commercial, industrial carbon removal would change. What you're describing is an attitude. It's an abdication of leadership, and if nothing, and climate change certainly requires leadership. I'll also say it requires a really comprehensive suite of policies. I mean, putting a price on carbon is kind of foundational. If you look at the jurisdictions that have been most successful, I think, in addressing carbon emissions, like California, they have a range of policies. I mean, they have the price on carbon through a cap and trade system, but they have a lot more than that. They have very tough CAFE standards. They have a whole series of regulations on top of that, and that's what we need. And you said you raised the well, you described it. You said it's a technology problem, not an economic problem. It certainly is an economic problem, and one of the the climate change denier arguments have evolved over the decades and years, right? I mean, first it was, well, okay, climate change isn't happening. Well, okay, now it's pretty undeniable that it's happening. And then, well, it's not caused by humans. And it's like, well, now, okay, it's caused by humans. And now mostly the argument is, well, yes, it's happening. Yes, it's caused by humans, but we can't afford to do anything about it. And that's exactly wrong. That's exactly backward, right? I mean, a stable, safe climate is foundational to prosperity. It's not something that we have instead of prosperity. And that's the message that needs to get out. And Rick is working with folks in the world of business and finance. Woodsville Research Center works with the folks in the world of business and finance. And when those folks, and I think those folks are starting to grasp this lesson, and when they do, they have very, very powerful voices in terms of being able to influence the political system, and I think that is an optimistic, it's an optimistic trend. The private sector is starting to get it, and they're starting to engage, and I think that's all good.
Technology cannot fix the problem by itself, and you see it in simple examples. The first time I bought a CD-ROM, I was willing to pay $20 for it because it was worth it back then. Today, there may be 10 cents or less. And technology got down the cost curve, but you had an entry point you could come in on because there was a value. Here, this is ultimately a garbage issue, and coal is so cheap that I can always have cheaper carbon than the one I can get by avoiding the problem. Now, you could be lucky, and the renewable energy photovoltaics is really so cheap that we don't want it anymore, except I'm still flying in an airplane. The last 20% you don't get out of the system even then, and you have to figure out how to incentivize that this is taken care of. So this is some form of regulation, some form of politics, and then learning by doing can make it affordable. But learning by doing doesn't happen unless you do. And the doing has to be stimulated by somebody saying you must do, right? Whether that's a tax or a demand for cleanup, we can argue what the right policy is, but you need to have a policy to make it happen.
And I'm going to point to the slide that's still up here saying the cost of doing nothing it's already costing us trillions of dollars as well as a lot of tragedy. This last thing over on the left is talking about that, global trade fell by 25% in the Great Depression, right? And we're talking about far more economic impact than that. And this whole, what got me started on what could I do that might buy us a little more time if our backs got up against the wall. This is what I work on as a backup solution I hoped we'd never need. And it was the thought that takes so long once we make up our minds to turn over the infrastructure, as you were talking about in your talk. It just takes a long time to get that done. And so, it's got to start now, the decarbonization, and then whatever we can do to be giving ourselves a little more time with a little less devastation to get that job completed is very, very important.
Any more questions?
Can I just say,
Rick has to go.
just let me say that one point to all of these is that one of our partners, Earth Day Network, Kathleen Rogers, the president of Earth Day, when we first started working together last year, she said, the problem is that restoration is the third leg of the stool, and it does not get any airtime. So we have to create an ecosystem that's policy change, demand for it, local government, celebrity engagement, business community. My old boss, Ted Turner, used to say, if you're going to be in the club, you have to go to the meetings. And the club is being a part of this community that's pushing for restoration. So, I'm getting on a plane Friday to go to Davos to work with CEOs. Last thing I want to do, but that's where they are. So you have to go to them and bring restoration to them. So creating this ecosystem so that all of these natural solutions, technology will come online, policy will change, but we have to demand it. And people don't understand it.
I might be one of those people, but I'll...
I was just 6 months ago, so.
My name's Julia Ernie Varga. I'll be speaking in the next panel, and I'm director of the Climate Change Initiative at the University of Massachusetts in Lowell. I wanted to, you brought up so many wonderful ideas, and my mind is I have so many questions that I could ask. One of them is this idea of restoration. So I think that it is important to clearly define that, and also to really, I would caution you in using the word restoration and with some of the things that you're talking about, but we can talk about that. Maybe I'm not understanding you fully. And also that, that as you've all said, reducing emissions has to be the first thing that happens in terms of restoring, or I'll just say stabilizing the climate, because to me that's what our goal is to stabilize the climate in as safe a place as possible. I wanted to sort of raise the concern that I have that you're talking about a waste management problem. My concern is that you're going to create a new waste management problem if this goes to scale. Now, of course, we need removals, as we've all said, but if we think about 100 parts per million, there are some problems in terms of radiative forcing of having 100 parts per million in the atmosphere as opposed to not putting it there in the first place, et cetera. We could talk about that. But just that amount of carbon, I think is something on the order of 635,000 Empire State Buildings worth of carbonate in terms of volume. And so if you just start to think about how much carbon we're talking about, are you thinking about how to, because of course you've got the 100 million or so, did I hear you right that it was 100 million containers, which seems doable given the scale of the...
This is the capture, not the storage.
The direct capture, direct air capture storage, that's the amount of equipment that would be needed. But each one of those containers is producing material that then needs to be transported, dealt with, et cetera. So I just want to, ask how you're communicating about that or thinking about that and where you think that should go.
In a way, I started there because right now I'm worried about negative emissions. When I started, I realized we had consumed at the time less than 400 gigatons of carbon, and there were at least 5,000 gigatons of carbon out there. And I felt it is necessary to have a technology which can balance this, because otherwise we'll always find a good excuse why this is attractive and we should ignore the CO2 emissions unless we can make it cheap. So that was my first question really was, where can we store all of that? And keep in mind, it came from under the ground too. So we have dug holes on that scale. Right? So we will have to put stuff away. And I would argue the 100 is the number you end up with if we phase out fossil as fast as we can. And if you're really lucky, it turns out it's 60. If you're unlucky, it turns out it's 200. If we decide that we keep rolling on fossil fuels, we are not talking about 100 ppm. That's at current rate 40 years of emissions. I'm basically saying 40 more years and we are done. Actually, I'm saying 30 years more and we are done, and I took the last 10 years back as well. That's sort of, I see us coming back to 400 is my guess. So I'm not even talking restoration. I'm saying in 1980 you had a chance of doing it without storage.
Yeah.
Now we are talking 1,500 gigatons of storage, and if you don't get your act together, you pretty soon are going to talk about 2,000 gigatons of storage.
Yeah.
Now, I'm optimistic that it's there. If you read the 2005 report from the IPCC, they are pointing to even larger amounts. Right? They say mineral sequestration has thousands and thousands of gigatons. They say underground reservoirs are worth thousands and thousands of gigatons. My view is that photovoltaics will win exactly because of this, because I also have watched oil prices, and I can tell you if there's an unlimited demand, which in the knots was driven by China growing a little faster than people had thought, and suddenly oil hit 100 and then 140, and I think it nearly hit $150 a barrel, not because it was so much harder to get it out, but you had an unlimited market and people were willing to pay it. If you now tell me we all have to store carbon, and by the way, 1,500 gigatons have to be put away, it becomes very hard for a power plant to say, and I put mine on top, because the price is not coming down. I think the biggest boost you can give renewable energy is to tie it into that story and say, we make synthetic fuels for those airplanes. And if the last 20% are hard, I'll give you another number. If you go to grow 2% for 80 years, that's a factor 5. Mm-hmm. That last 20% in 2100, quite likely, is as big as our current emissions. Right? And so you want to close that carbon cycle as much as you can. And I see photovoltaics or renewable solar energy, and maybe some wind, but mainly solar, run the system, and you store a large fraction of it in chemical fuels. For an hour, you put it in a battery. For a day, you probably put it in a battery. If you deal with summer versus winter, you better make chemicals. But you have to find room for the 1,500. And my initial reaction to this is, I don't justify this anymore because you don't have a choice. It's a little bit like saying, I have lived well over my means, and I'm now telling you I'm going to save. But I'm not going to take a job because I'm not going to earn money, but it turns out my savings, but I can't save enough. Right? So we now have to figure this out, and the good news is if you add up how many gigatons of carbon you can put into rock and pile it up literally, and how much you can put underground, like for example in Iceland in the basalts, you probably have thousands of gigatons. But we need to demonstrate that too, and if it turns out that's wrong, well then you're stuck with a lot of CO2. As Gavin pointed out, we either mitigate, adapt, or suffer. And I think you will find the suffering route becomes more and more likely if we can't figure it out. But I'm actually optimistic that a couple thousand gigatons you will find.
Okay, I have more questions, but I can hold them if that's.
Well, do we have other? Yes, please come forward.
Hi, my name is Zach Decker. I'm a PhD candidate at University of Colorado Boulder. I'm also a researcher at NOAA through a cooperative institute. Hi, Zach Decker. So I'm a PhD candidate, and I'm also a researcher at NOAA. And in the budget that just passed a few weeks ago, it includes money for things that involve research in climate intervention. So nothing specific, but some ideas would be things like cloud seeding or aerosol injections. The question I have is really broad. I'm wondering if you guys would comment on this. As scientists who are starting to research in this area, there's a lot of ethical questions, of course, and it's a new field. It's not so much mitigation, but it is intervention. I'm wondering if you guys want to comment on this form of
I should probably go first.
You
Right.
are in that bracket.
Right. Okay, yeah, I'm an intervener. So I think there needs to be, fair assessments of what happens. Not up to the individuals who are developing certain technologies. So we said that. So let's have a neutral framework. I was very quiet about what I did for a long time because I was worried that it would be seen as exactly the risk, right? The moral hazard argument of if the engineers are going to take care of this, then we don't have to change a thing we're doing and we can go on burning coal and, opening up, more oil reserves. So that's a risk, if that's one thing you're saying. And I think there are things that, this whole climate restoration thread excites me in that it is going down a path of a natural solution. So we're trying to replace things that until recently were there. So these, a bunch of these restoration efforts are really trying to bring us back, help us back, reboot some processes that are getting lost, give some time to fix the original problems, which are, all these excess pollutants. There are other paths that, go down different paths that we've never seen before in our climate or seldom seen. And those strike me as, in general, riskier and need to be, they all need to be held to the first standard of what I regard as the first do no harm, right? In any intervention, though, we can see in our climate modeling, you want to thoroughly vet things out. There will be winners and losers. And so that's, again, why you need some neutral party to say, yes, okay, most of the world, the sea level rise is less, we're more likely to meet our sustainable development goals that we have, we're going to be, helping this ecosystem in a big way, but those guys are going to have it a little drier or a little colder, right? And you need to balance these judgments. This needs to be part of that system that people are beginning to set up, this governance. But with all of those things considered, the cost of doing nothing is utter tragedy. And so it's time to really get serious about pushing these various restoration efforts over that goal line.
Yeah, if I can add a comment, I agree with everything you said, Leslie, and what you're talking about, the term of art for that is geoengineering. Nobody likes it. I don't like it. There are all kinds of problems with it. Moral hazard is one of them. It doesn't fix climate change. It introduces a partially compensating, in effect, that partially compensates for some of the manifestations of climate change, at least as we understand it now. It doesn't do anything to address ocean acidification, which is a serious issue. And the governance, as was alluded to, the governance of geoengineering is a complete nightmare. But that said, I do think it's, at this point, it's crazy not to study it.
Yes.
In particular, to me, one of the main reasons for for the need to at least study geoengineering is, in fact, the Arctic. The things that worry me in the Arctic are two, and one is greenhouse gas emissions from thawing permafrost, which are a big amplifier on climate change, and clearly those emissions are happening, and they're happening in a very substantial way. We actually published some work on this in November in Nature, showing very substantial carbon dioxide emissions in winter from thawing permafrost. I think that the emissions in the wintertime emissions are something like 16% of total human global emissions. So that's a big amplifier, and of course the worry is that permafrost thaws, it adds greenhouse gases to the atmosphere, that makes more warming, more permafrost thaw, and you're off to the races, and that's a real nightmare. And the other real issue in the Arctic to me is the Greenland ice sheet, and clearly that's losing mass. Clearly that mass loss is accelerating. It will take centuries, no doubt, it would take centuries, I should say, for the ice sheet to disintegrate completely. But where's the where's the threshold? Where's the threshold beyond which that complete loss of the ice sheet becomes inevitable? We think that threshold is actually pretty close. It may be like 1.5 degrees, or somewhere between 1.5 or 2 degrees of warming. And so it's super, and obviously if that threshold is crossed, then what we're doing is we're committing our descendants to 20 plus feet of sea level rise, which is a pretty sobering thing to think about. So I think for those reasons, it's essential to think about geoengineering, and in particular, can we geoengineer at a minimum just the Arctic, preserve the permafrost, preserve the Greenland ice sheet.
Let me give you one more reason why I would encourage you to study it. I agree with you that we may very well need it because we have enough of an emergency that we need to deal with it. I liken that to putting a tourniquet on your bleeding in your leg, but just make sure it wasn't your neck, right? And also don't walk away from it and think you solved your problem, right? You bought yourself time. But I'm also concerned that particularly solar radiation management could have outcomes you really do not want. On the other hand, it's also very cheap. So if there is a crisis, we're going to say we need to do something, and this is what we're going to do. I'd much rather have you have studied this first and tell me, I think it's okay, or you tell me, don't ever do that because it's really a horrible idea. Right? And I would like to know that before we are in a crisis and have to answer it. And so the simple fact to say we shouldn't study it because then we might do it, I would actually see it the other way around. Because it's the cheapest solution, which people will perceive as the cheapest solution, they will jump into it when there is a crisis. And you better know what you're jumping into. And if you tell me this is really full of snakes and nasty things, you shouldn't jump into that water. I'd like to know that before. So I think studying it, not necessarily as an advocate, right? But what will happen if we do that is very much worthwhile.
Thank you. I have a question for any of you panelists. What messages would you like broadcast meteorologists to take back to their colleagues at home, at the station, the staff, and to their audiences back home?
We probably need a better term because I agree with one of the questioners about there are things about restoration. The term being a restorationist, it can imply all kinds of different things, but I think that taking the term back home, that everyone can demand that their local government, their local business, their local schools, that there are people need to become educated, that there should be mitigation, adaptation, and restoration. We do need to research, we do need policies that need to change, but that they have a voice and they can actually activate in the local market.
I'd advocate, and this is being somewhat redundant with the previous session, but that we inform people enough that they know there's a real problem, and that we don't terrify them so much that the brain shuts off, because that's just hard. And so you threatened that I'd mention my class. I teach a class every fall at Stanford on engineering, entrepreneurship, and climate change. And in the course of that, I help some really worried students who show up, more this last year than ever before, quadruple my previous enrollment, help them to go from being just worried to death and wondering what the heck they can do, to seeing a series of really interesting solutions that people have come up with and are eager to come and share. And so sharing that good news too, that there are people working really hard on these various options, and that the worst thing we can do is give up. And we just can't terrify people into taking action. That's not, you have to help them find a path to do something constructive.
In a way, climate change is not all that hard. Fourier understood it in 1824, and the data coming in, what gases are greenhouse gases. He just said something in the atmosphere determines the temperature, but we don't know yet what. And then Tyndall figured out it's CO2 and water vapor. And Arrhenius, before the 19th century was out, could pretty much tell you how big climate change is if you if you put enough CO2 into the atmosphere. So it's not all that hard. And the debate about whether it's real or not, I think is really past. I think we need to start thinking about, okay, what do we do about it? I did come in it from, we have to solve the environmental problem, but I also come from the perspective, human societies will need energy. We will have to figure out how to have energy at the end too. And I would argue the biggest sustainability crisis we can run into is that population growth doesn't stop. The big optimistic news you see today is that population growth is leveling out. But if you ask where is it leveling out, it's leveling out in the developed countries, which have the wherewithal, the education, and the standard of living for this to happen. If we block access to development by making energy so expensive that developing countries cannot develop, the population growth will proceed until it's catastrophic. So if you look for a hopeful outcome, you better make development work at the same time. And that means we have to figure out how to have energy. And I think the optimistic part is that renewable energy is now getting cheaper than fossil energy, but at the same time, it's intermittent. So we have to solve this intermittency problem. And in part that will be batteries, in part that will be that you make chemicals. If we can make hydrogen from solar energy and we have CO2 we took from the air, you can make any fuel you like and any chemical you like, because we started otherwise from methane and oil and coal. So we can get to that starting point entirely synthetically if we have the energy, and it looks like we might.
So, well, the question was about, well, what can broadcast meteorologists do? And I'll say one of my frustrations with news coverage of natural disasters is, it focuses naturally enough on the human dimension and, the horrors of people floating away. But when I hear that coverage, what's going through my head, particularly coverage of recent hurricanes, is how just the manifestation of these storms is so consistent with what we expect from climate change, even the very, very specific properties of the storms. I mean, it's well known that climate change causes hurricanes to become more intense, but what we've seen is other aspects which are also predicted consequences of climate change. For example, this very rapid intensification where these storms go from being sub-hurricane intensity to category 3 or 4 or 5 within 24 hours. And that is made possible by warmer temperatures. It's a predicted consequence of climate change. So is this slow forward propagation, which we've seen in several of these prominent recent storms, in Houston in 2017 and the recent storm in the Caribbean, where it essentially stopped moving, and that has enormous consequence because it means it's sitting there dumping, and it's dumping at a rain, and it's dumping at a very, very high precipitation rate because the atmosphere is warmer as a result of climate change. So all of these things are exactly, even without a formal attribution study, you can say, look, these are predicted consequences of climate change, and this is what we're seeing, and we see it over and over and over again. And I think there's a real opportunity there to educate the public about the role of climate change and extreme weather. And Climate Central, actually, when I was there, started to do that, and I think they're still doing it. I think it's a great idea, meaning work with TV meteorologists and give them some material they can use to help educate folks about the role of climate change in these extreme weather events.
Great. Do we have any time left? I think we're
5 minutes left.
Okay, please. Yeah.
Hi, my name's Evan Chip, and I've done a lot of photochemical modeling in my life that went into environmental impact statements. And so my question is there a kind of a social mechanism available to weigh out the consequences of doing environmental engineering in the world right now, or is that something that would have to be developed? I mean, you talked about you talked about this silica stuff. I assume it's particulate, right? Mm-hmm. Right, and there may be just that particular example. You might have impact from particles if you do these things.
Yes, these are hydrophilic, so once they're distributed, they're going to cling to the ice or water surface. We make sure they're big enough they're not an inhalation hazard. But we continue to look for the first do no harm. If we find, we're perfectly willing to pivot on the materials if we find that there's an issue. That's a firm commitment. That's you know, I'll be dead before we violate that, right?
Okay.
But that's, yeah, that, if that's what you're asking.
Right.
But the other thing is
Yeah,
a lot of.
that
yeah.
was specific. Just
Yeah,
because,
ecotoxicological
Right.
testing
Right.
and climate modeling, really for, yeah.
But I think my question's more about, does that social mechanism exist right now to really weigh out what environmental type engineering impacts would be?
So what we call that, and what we're trying very hard to provoke, are governance frameworks, permitting frameworks, the whole safety mechanisms that are impartial, that the people themselves doing these things are not in charge of. And that's part of what Rick's
One of the
doing,
things
yes.
we're doing next week is we're gathering governments, corporations, individuals, foundations. There's a group coming together to call for a task force on exactly this kind of an issue, that these things need to be tested. We do need policy change. There is the entire UN framework that will, you know, we love the UN, but it'll take forever for some of these decisions to happen. So how can we build this outside? We did this 20 years ago with the AIDS crisis and created the Global Fund for AIDS as a way to jumpstart. So we're looking at this as how do the different partners come together. We won't be able to solve the problem, but we can call for a task force to think through these different issues from all the different perspectives and then bring it back to some of these global bodies like the UN.
Yeah, see another one, come forward, please.
Hi there, I'm Eric Klobus, and I'm an environmental engineer postdoc at Harvard. And my question is the following: how can we deploy this climate restoration and enforce the necessary metrics while respecting the energy autonomy of developing nations? This is kind of open-ended. I'm just really curious.
I give you a simple example. You could say, take a poor country in Africa, pick Mali. We could say, you know, you need to develop and don't worry about your CO2 emissions, we can take care of it. You could have a debate with India, which is basically saying, as far as the carbon pie is concerned, you ate it all, and now we cannot develop. We could have an agreement that we have to take back old carbon, because our budget, we overdrew our budget. So you suddenly have actually the ability, because you can now negotiate who is responsible for the carbon. And India is telling the developed world, you are responsible for all the carbon, and by the way, you prevent us from developing because now you expect us to do something which is more expensive. I hope we can help them leapfrog, but to the extent that they cannot, we can open the door for them by saying, we'll take your carbon back, which is not restoration, but it goes into this negative emissions idea. You could say the developed countries have to take back some of their carbon budget because they went and ate the whole pizza, and now they have to bake a new one.
Yeah, Rick, please.
I'm very interested in that answer you just gave, because what we hear from our lawmakers is, why should we do anything if India is going to pass us up? So it's exactly the reverse of what you're saying.
Well, I get that. I get that, but it's also, I think one of the things which shaped my thinking about a decade ago was the little Tata car. And I sharpened the debate, but the New York Times had an article which basically said, if they do that, we are screwed.
Yeah.
Right? And I get your point, but if you just honestly ask yourself, we got rich on carbon.
You're absolutely right.
And we owe the rest of the world some carbon. Now, I see that this is politically very difficult, but you can have negotiations. And I go back to Reagan, who suddenly felt that he needed to give something to Canada, and suddenly we could solve the SO2 problem. So things like this can happen once you have the wherewithal to make it happen, but you have to put it into the hopper for it to happen. If you never talked about it, no politicians will ever think about it, and it clearly will be a quid pro quo. If we give India that, we wanted something in return. I can assure you that.
Yeah, I would just wanted to make the point that it's really difficult to sell any kind of policy without addressing that question. about China and India. In fact,
Well, China is actually in a very interesting point. It's basically balanced right now compared to the rest of the world. And they are moving into our camp. But for a long time, yes, their per capita emissions are going up, but compared to ours, they are puny. If you take all of America together, we would be north and south, we would be equally big, right? But
yeah, some of the politicians tell us China isn't going to do anything till 2030, which of course is
It's a load of crap.
terribly distorted.
But they have done more. They have done more than we do. And being in a society where somebody on top can say, "And now we are going to do it," it's actually easier.
Yeah.
So I'm not too surprised. But there's a flip side to this too. This is going to be $1 trillion effort on an annual basis, whether you like it or not. And I just made it cheap. Would you rather have the $1 trillion of employment here or in China? And if we sit here and say, well, the Chinese are not doing anything, one day they are, and then we pay them to solve this problem.
So I got to get my 2 cents in here. So
Yeah.
first of all, it's simply false that the Chinese and Indians aren't doing anything. It's simply false that the Chinese are spending more on renewable energy than anyone. But I think the main answer to that question is, what about leadership, right? Since when does the United States say, well, we're not going to do anything until the other guy makes the first move? I mean, that's a complete abdication of leadership. And I'll give you an example of how that works, which is exactly germane to the instance you cited. So when Obama was president, in the run-up to in the run-up to the Paris Agreement, we had one of my colleagues in the White House Office of Science and Technology Policy, Kelly Gallagher, who's now a professor at Tufts, was brought to the White House to negotiate in secret a one-on-one agreement with China. And she did that, and it worked. And those were the U.S. and China were at the time, and still are, the two biggest emitters. And those negotiations culminated in a joint announcement about a year before the Paris Agreement of our commitments. And they were non-baloney commitments, really significant commitments on the part of the two biggest emitters to reduce greenhouse gas emissions. And that's leadership. And the Chinese commitment was that they would maximize their emissions by the year 2030, which politicians have mischaracterized as, well, we don't have to do anything before 2030, which is complete nonsense. But the way leadership works, and I remember in the wake of that announcement, we went to visit India. We talked to the Prime Minister there, and I can tell you that announcement really got his attention, and he was basically thinking, okay, crap, we got to up our game now, because I'm the third biggest emitter, and I got to get with the program. So that's leadership, and that's how leadership should work. And sitting back and saying, we're not going to do anything until the other guy does is pathetic.
I want to point out that one of the reasons Rick may have asked that question is that being with Citizens Climate Lobby and being in front of legislators all the time, we really do get our fingers on the pulse of what they're thinking, and that is the kind of thinking that we get a lot of. And so it's really helpful to have your folks' input on how to counter that attitude. Thank you. Thank you. More questions? We have probably time for one more. Oh, going, gone. Thank you very much.
Lunchtime.
Thank you.